Good afternoon, ladies and gentlemen. I think we can turn down the music. Thanks for coming back and welcome to this afternoon plenary or panel session, which I have the honor to moderate. Let me just introduce myself. My name is Christian Feichting. I'm the Executive Director of the International Astronautical Federation, which is an international federation bringing together more than 600 space organizations from 82 countries. We have our headquarters in Paris. And our motto is connecting all space people. So I'm very pleased to be joined here with so many distinguished speakers, panelists here from all over the world, actually. And the topic of this panel, which I welcome you all, is the future of human spaceflight, new orbital stations and formats of cooperation. So let me start by introducing to you our distinguished speakers here. I go from left to right. Sergei Grikalyov, who actually I don't think needs any introduction to anybody here. He's now Deputy General Director for Manned and Automated Systems at the Roscosmos State Corporation for Space Activities. Okay. I'm not up to date then. But Sergei doesn't need really an introduction, I think. I mean, you know him all. Next, we have Mr. Humbulani Mudau, who is the Chief Executive Officer of the South African National Space Agency. Welcome. Next is Mr. Baubek Oralmamambetov. He is the chairman of the Aerospace Committee at the Ministry of Artificial Intelligence and Digital Development of the Republic of Kazakhstan. Welcome. Next to him, Mr. Azir Bakirajai. He is Director of Propulsion Complex at the Indian Space Research Institute, ISRO. Welcome. And then we have Mr. Ivan Bucha, who is the Deputy Head of Aerospace Operations Directorate at the National Academy of Sciences of Belarus. And last but not least, Anatoly Petrokovich, Director of the Space Research Institute, IKI of the Russian Academy of Sciences. Let me give you a short introduction about the situation we have today and what we are going to face in the near future. Today, of course, we have at least 2 space stations in low Earth orbit. Last year, we've celebrated the 25th anniversary of the permanent human presence on board the International Space Station. And Sergei, you were a member of the first crew that initiated the operation. Very good. So this ISS, as you all know, is based on a partnership of 5 main partners: Roscosmos, NASA, the European Space Agency, JAXA, that's the Japanese Aerospace Exploration Agency, and the Canadian Space Agency. We have seen more than 300 individual astronauts visiting this station from more than 25 different nations. So it is really a symbol of international cooperation in low Earth orbit. And with the work on this station, I think space communities from very different countries, nations, and with very different engineering cultures have learned very well to work together in preparing, developing, and operating such an outpost in near Earth orbit. The lifetime of the station is, of course, also limited. It should come and will come to an end by about 2030. That's the dates they are discussed at the moment in order to stop operation. The second station is operated by China. It is the Tiangong station that is operational since 2022. No foreign astronaut yet to visit this station. So far only Chinese astronauts. Also international cooperation, scientific cooperation and experimentation is going on internationally. And this station is also planned for a lifetime of 10 years, so we'll at least have this station up to 32, maybe longer, 35 in orbit. But considering now specifically the end of the lifetime of the ISS, of course, everybody, all the different countries are looking in what comes next, and there is a very clear transition which we see today from a cooperative development and exploitation of stations to national stations and to commercial stations. That's what we see. What will be the actors in the future? I see four main actors. Of course, Russia will prepare its Russian orbital station, which will be a national government-driven station. The US is going a totally different way, where the government gives the US industry the opportunity to bring to orbit commercial stations. And we will see at least four actors in the US. Axiom Space is preparing their Axiom station. Blue Origin and Sierra Space, the orbital reef as they call it. Voyager, in cooperation with Airbus, actually is working on Starlab, and VAST is preparing Heaven 1. So we'll be curious to see which of these four will be first and whether all the four will really appear. China, the third actor, will continue, of course, the operation of the Tiangong station, and it remains to see what comes afterwards. And then, of course, very interesting, India joining now, also or intending to join, planning to join the human spaceflight community with its Gaganyaan program, and, of course, the Indian space station that is planned to be hopefully hear more about this, operational in 2035. So what we want to focus on this panel actually is on several questions. How will this change in the landscape in low Earth orbit impact future collaboration schemes? Because today we know who is cooperating with whom on which basis, but with this change, future will be different. How can the expertise that was gained through this cooperation on the ISS be preserved also for the future? And what challenges and opportunities will this new landscape also bring to all the different participants? So with this, I would like to turn first to Sergei and ask you, of course, a question that is very close to your heart, I'm sure. I mean, with all the experience which you have on flying with Russian systems, US systems, being on the ISS, the first managing Russia's participation in the ISS. How is your extensive experience on the ISS being applied in the development of the Russian orbital station? And what steps do you see are being taken to prepare the Russian orbital station for this new emerging architecture that we see in low Earth orbit?
Are we speaking English or mix Russian and English language as we do on ISS? English?
Your preference, your preference. I think there are translation, interpretation services available.
What is the requirement?
No requirement, either English or Russian. Don't take anything else.
So let's, pretty complicated question, but I would first like to clarify what means international station, because sometimes people put in opposite sides, international and national. Really, and Christian, we met first time in 1991, I guess, right?
Even 90, or 91 maybe.
90, probably 90, I agree with you. So many years ago, and you remember it was preparation for international mission on Mir station. Mir was a national station, but international cooperation was a big part of space exploration together already on Mir. So when we are talking about national stations, it doesn't mean that we are not going to do international cooperation on it. Probably type of cooperation could be a little different, but again, we have good experience of flying together on national stations, on international station. We have experience of doing experiment together or do separate programs even on the same station like ISS. Sometimes some experiments, some activities are done in coordination, but independently by every country. So I think what is going to happen in future, that Russian space station, which is now in design phase and production phase, would replace Russian segment of International Space Station for Russian program. But my guess, and I'm sure actually, that it's going to be international in the way that we would continue joint flights. We are going to do joint experiments, and I think even if we have several stations, and that's what probably will happen in nearest futures, in nearest future, we would be able, we are going to build the program in such a way that we would be able to cooperate. And cooperation can be in many different ways. One of these is joint flights, what we did on Mir, and what we are doing actually right now, doing what we called перекрестные полеты, or Americans call it integrated crew, but basically it means that one representative from another part of the program, US side cosmonaut is flying with us on Soyuz, and one of Russian cosmonauts is flying on Dragon or maybe Boeing in the future. So the same may happen with the station, even if they fly on different orbits. But now we are understanding that being in a similar orbit, maybe not even on similar orbit, but in same plane, will let us opportunity to fly from one station to another. And we already have experience of doing this when Expedition 1 on Mir station flew from Mir station to Salyut and then return back on Mir. So if we are going to fly in compatible orbits, we can do our independent program, and we can do something together, flying together with each other. And that's why we are discussing orbital configuration. We probably need to continue what we are already doing for several years, develop some of the systems in such a way that it should be compatible, like docking ports, communication system, maybe electrical power system. So it's up to technical discussion for the future, but we need to do at least something compatible in order to be able to cooperate with each other, and that's where we are right now.
So even if we are going in the direction of national stations, not cooperatively developed stations and operated stations, Russian orbital station will still be open for cooperation.
Yes, it's, we already declared that we are going to have it open for cooperation. Actually, Chinese is also declaring that they invite people to cooperate with them. It doesn't happen at this time, but it doesn't mean that it wouldn't happen in the future.
Yeah, maybe one quick follow-up question, just to give us a sense of the timeline for the development and put in operation of the Russian orbital station. When can we think or expect this to be?
The way we are going to build this station is start building it on the base of International Space Station, on base of Russian segment. And this is actually what scenario we discuss when we transfer from Mir station to ISS, suggesting that maybe Mir can be some kind of basement for developing of new stations. So that's what we are going to do right now. We are going to dock modules of new station to ISS and then undock when time comes. And I guess it may happen also with the same with American segment, because they are discussing to have at least some modules dock with ISS first, and then when they going to be checked out and ready to fly independently, then they can undock and fly independently.
Yeah, that's at least for the Axiom station, the plan.
Yes.
Thank you, Sergei. Let me move on then to Mr. Mudau. There is a saying that space... Yeah, please, give an applause. There is a saying that space knows no borders. Of course, to a certain extent, this was true also for the ISS, but we need to admit that the ISS partnership was still limited to the 5 main partners and, of course, a handful of other countries that were invited to participate. Now, you're representing South Africa, and dynamically developing emerging space nation, also interested in getting into human space exploration. How can nations like South Africa protect, on the one hand side, their national interest, and how can you take full advantage of this new landscape where you have so many different options to choose from?
Good afternoon, and thank you, Christian, and greetings to all the panel members. I think, let me start by just saying that we are all witnessing an era in which I never thought in my lifetime I'll witness this. So it's scary on the other side. It's also challenging on the other side. The world that we're living in today, it's so volatile and so unpredictable. And therefore, that, of course, for us poses this challenge of looking at nurturing relationships with strategic partners that are like-minded, partners that would assist us in advancing our national interest, particularly building the space capabilities. And we're seeing that happening right now in South Africa. Over the years, we've built a very broad global space relations and partnerships. I think we're the first one to be the signatory to the ILRS, the International Lunar Research Station. And that, of course, was necessitated by the fact that we have this ambition and the inspiration to see a South African, to see an African child one day going into the International Space Station, or one day going into the moon. And therefore, for us, I think this opportunity presents a huge opportunity for the emerging space nations. I think for us as Africans, and the ambitions that we have established the African Space Agency. We believe that through the relationship that we are nurturing right now, that will create a lot of opportunities for us to be able to contribute. We have been working very closely with Roscosmos. As you may know, we host the Space Debris Monitoring Complex, and that on its own just open up a number of opportunities for young South African to build human capital in the area of space sciences. And we should always remember, with all these ambitions, that the research and development is so critical. And therefore, we see ourselves playing that huge role, but also inspiring young Africans, not just South Africans. And therefore, we are seeing this as South Africa as a huge opportunity that will also ensure that we do see our presence and playing a significant role in providing leadership, not just in South Africa, but in the African continent, as well as bringing in the global South to contribute. As we know, the space economy is growing quite significantly. And of course, our signing with ILRS has given us an opportunity to further engage with Roscosmos on what our role will be in the future ROS and human flight in terms of cosmonaut training. But we're also seeing ourselves in 2028 in partnership with the Chinese National Space Agency, our presence at the moon with the experiment that we'll be putting there. So I just want to stress the point that, I think what we're seeing this new dispensation is going to create a lot of opportunities, unlike during the ISS where a few countries were able to participate. Thank you.
Well, thank you very much. It's great that you stress the impact, especially human spaceflight and astronauts have in inspiring the young generation, because that's, I think, our future. And if you allow me to follow up on a quick question, of course, it's great already the step to do joint experiments in microgravity, to join also the ILRS. Are there any plans to go further in thinking of building up or doing a contest for South African astronaut to be flown with whomever to the Russian station, to the Chinese station? Are there any plans?
Absolutely, Christian. So I can tell you that we are working on the plans. We've had an offer from Russia. And thank you, because of the relationship that we've had over the years during those dark days, and we're really appreciative of the gesture, but also of the opportunities that we're getting. So we have that offer for cosmonaut training. And for us, goes beyond just South Africa, as I said earlier on. It's about inspiring young Africans that are more than 70% of them in the rural areas are disconnected because of the digital divide. And we're hoping and we believe that this partnership that we're forging, of course, within the ILRS, would also create this opportunity and exposure to an African child, so that they can also believe that they can have a future in science, engineering, and technology. Thank you.
Well, thank you very much. I think it is so key that South Africa is playing a leading role for not only for your own country, but also for the whole continent of Africa. Thank you. Let me turn now to our next speaker, Mr. Oral Mammadov. Russia and Kazakhstan, you have been maintaining strong and very enduring collaborative projects like, of course, the operation of the Baikonur Cosmodrome, but also the co-development of environmentally sustainable launch vehicles. Let me ask you, how does this project BITEREC, which is around since I can think of, I don't know, more than 10, 15 years or 20 maybe even. How does this project fit into the future of human spaceflight launches?
Thank you for inviting, and thank you for the question, quite interesting. And I would like to say that with Russian Federation, our partnership is strategic. And if indeed we are living in a unique time, unique era, when the space industry, some of the areas of space industry becoming critical infrastructure of the countries, connection, it's remote sensing of the Earth. And sometimes we can see some confrontations. But still, in the international cooperation really means piloted missions. And it would be great to have it as further as the face of international cooperation. As Sergei Krikalev said, despite the fact that those stations are going to be national, still they will do international research. And Kazakhstan wants to participate in those new projects, of course, in the degree we can afford. Speaking about BITEREC, indeed, It's a project, and you said right that for a very long time been implemented. It has gone through several stages. And at some point we even thought that it was suspended. There were different, things. But still, the project is like our relationship, and when our trust with Russian Federation becoming stronger and stronger. Because, doing such global project where two countries synchronize financing, synchronize human resources, specialist competences, that's all about trust. And this project now is at the final stage. The first launch is expected shortly, one of these days, and I hope that in several days we will all hear the good news. So that is why, after those flight tests, of course, there is an idea of using the Soyuz 5 Sanvar, we call it Sanvar, not only to place space vehicles, but also possibly cosmonauts out into the space. Of course, there are a lot of technical issues. There will be a lot of technical issues, I'm sure, because that's a new level of our goal. And as you know, to launch cosmonauts and to provide their life there is the most difficult task today, which is being solved. And of course, if this happens, we will be only very happy. And of course, there are some engineering ideas that we can offer as to how cosmonauts could be squeezed into the rocket, and what kind of infrastructure should be modernized for that. And the people who visited the Cosmodrome, and they have seen the pad as a symbol of the fact that they wanted to launch cosmonauts at some point. There's a big, we call it birdhouse, there's a big railed structure which should be coming close. And we put it there. We still, for us, to serve as a reminder that at some point they wanted to launch cosmonauts there, and I hope that it will happen one day.
Indeed, I also personally, and Sergei will agree to that, have very good, excellent experience also in cooperating with Kazakhstan. I mean, the first flight, which I had the pleasure to work with you to the Mir station of an Austrian astronaut, to the Mir station together with Sergei, also included in the crew a Kazakh astronaut, Mr. Abakirov. So it's very, very obvious that Kazakhstan has always played a very important role in human spaceflight. Let me follow up maybe one question to you. Do you presently have a Kazakh astronauts class or crew team? Are you training astronauts? Are you selecting astronauts already?
Yes, sure. Yes, we would like Kazakhstan to participate in those piloted programs, because we had 3 cosmonauts which did 5 scientific programs, 5 flights we had, and we are reflecting on that. And our public, as I said, the face of the cosmonauts of the space is piloted. Some might get offended, but the public also is expecting and waiting for new astronauts, and the Kazakh community asks us all the time. And in the framework of the interest, there are some scientific research initiated in Kazakhstan, which could be the basis of the next missions, of the future missions. Additional initiative is that last year we held an interesting experiment. We created a capsule resemble to the ship which is on the ground. And when astronauts at the station up there, of course, there are difficulties with their life providing or life, but we have to remember that socialization is a very important factor, because they are in a very concealed space. There can be some psychological problems, and we started with girls. We put 4 girls in the capsule. Very interesting experiments we started, and I hope that we will continue this year, because we want to continue those experiments and to share the results with the professionals. Maybe they will help us out. And today, Kazakhstan, we are actively experimenting on ground. And in the future, of course, it would be great to do the microgravitation with Kazakhstan scientists, because they are asking us and they initiate projects. Thank you.
Well, I think we all agree that we all look really forward to see another astronaut from your country in space. So thank you very much. Let me turn now to our next speaker, Mr. Bhattacharya. India is today one of the few countries that is capable of independently developing and producing a full range of space propulsion engines. And of course, with all these engines will be very much necessary to be available for the next step India is taking in order to bring the Gaganyaan program forward, but also, of course, to be offered maybe to an international market as well. How will the growth of the number of stations which we will see in the coming future affect the space industry, and what impact may that have on the propulsion market in general and specifically for India?
Thank you, Mr. Christian. Very good afternoon. I bring greetings from ISRO, the Indian Space Research Organization, to all of you. As you are aware, India, we have been working with different propulsion systems. Basically, we started with societal applications. We started with the vehicle called PSLV, and then we graduated to GSLV. Then we are presently having a vehicle called LVM-3 Launch Vehicle Mark III, which uses the explorable solid and the cryogenic propulsion systems, which is capable of lofting something like 4.2 tons of satellite into a geotransfer orbit. The same vehicle was used for the Chandrayaan-3 mission, which we had the landing at the south pole of the moon for the first time in the history. And then this vehicle is going to be used for the Gaganyaan program also. And the Gaganyaan program, as you are aware, we are going to have a low Earth orbiting mission with a couple of crew members for about 3 days to 7 days. And this propulsion system is going to be available for the Gaganyaan program. And later, we are also working with bigger systems for having an eye on moon, to have the Indian astronaut going to moon. We are working for the future launch vehicle systems and the space transportation systems. Now, coming to your clarification regarding the space sector, the industries, their participation in the future of space stations. Let me, before answering to your query on that, I would also be very happy to inform that India is in the process of making a Bharatiya Antariksh Station. There's an Indian space station in the orbit of about 450 kilometers with an inclination of about 51.6 degree, which will be getting co-located with the Russian orbital station. In fact, with the rich experience of Russian colleagues, we would like to partner with them in the development of the Indian space station, what we call it as BAS. In fact, we are looking for a partnership. We are looking for cooperation with various agencies of different spacefaring nations across the world in building our space station, which will be of totally about 54 tons of mass with 5 modules, which is going to be launched from the year 2028 to 2035. That's a plan. And we have the vehicle ready for those launches. And the initial configuration finalization and the system level finalization have been happening, and we are in dialogue with our partners, and we get very encouraging support from the partners across the world. And as you are aware, the cosmonauts training has been happening in Russia, and we really, the GCTC, and we really thank our Russian partners for doing so. And we could, historically, when we look back, 40 years back, we could get an opportunity of flying the Indian astronaut in to Soyuz and the station and Russian space station. And recently, in the last year, we had the opportunity of flying the trained astronaut again in the recent generation to fly in the Axiom 4 mission. So the participation of India in the global space stations, whether it is Russian space station or the International Space Station, we are there with the rest of the world. And our space station also is going to onboard a lot of good experiments, and we also look for partnership in carrying out the experiments in the space station. We are going to articulate the space station based on the need and the participation of various space agencies across the world. And India has been always a country which is looking for making use of the potentials of the space for the benefit of the human being in uplifting the human values. So that we will continue to do that in the space station also. And then coming to the participation of the private industries and their partners across the world in the space station will be, or in the human space flight program for the future. As you are aware, India, to start with, 5 years back, we had only about 2-digit or 1 digit of private industries participating. The entire space ecosystem in the country has been changed with the new space policy which was introduced by the government in the year 2023. Now we are having about 400 private companies which are playing in this space area. And they are not only complementing the Indian space program, they are also trained enough and partnering with the rest of the world to support the space programs across the world. Actually, I would really present to this August forum that they become the real ambassadors of the Indian space program, because they are able to acquire the knowledge and training of aerospace culture through the Indian Space Research Organization, which they are able to complement not only in India, in other countries too. And certainly, the making use of the cislunar space in the future is going to be a great dividend for all of us. And I'm sure by such conferences, such gathering, we get a good connect, and we have a deeper insight into the partners' appreciation of the activities on the space. And we are there with you. India is there with the rest of the world to complement, to cooperate, to support and provide services and derive services. Thank you.
Well, thank you very much for this very, very nice insight. And I can only congratulate India, of course, for the development of such a vital industrial ecosystem, space ecosystem, which we had the pleasure to hear in details actually when we organized last year together with ISRO the Global Space Exploration Conference in New Delhi, which was very successful. And it's also amazing that India is not only focusing on one single partner. You have mentioned it, the flight with Axiom on the US side, the cooperation with Russia, flights on the ISS. Let me ask maybe one additional question from the outside. What are the plans of India to allow also non-Indian astronauts to visit the future BAS station?
Yes, sure. No, when I was just presenting to you about the preparation of the Bharati Antariksh Station, the BAS, in cognizance with the Russian orbital station, we are going to be there in the same inclination. Actually, we are looking for a lot of good cooperation with the Russian friends to have common subsystems for control, for powering, for communication, for tracking. And certainly, as you initially mentioned in the beginning, space doesn't have any border, either political or physical. So we need to work together as a humankind for the upliftment of the entire global community of humankind. So certainly, we will be taking on board the astronauts from other spacefaring nations, and vice versa. We'll also continue to participate in the space program of the other countries in sending our astronauts to their stations. Thank you.
Well, this is very, very nice to hear. I mean, we have two representatives of countries that will have their station in orbit sooner or later, and both confirm that the station is open for astronauts from all over the world. So I think this gives us really hope that cooperation will also be in the future a major point to make progress in space exploration. Let me now turn to Mr. Pucha. Yes, please. Collaboration on Earth often forms a very strong foundation for collaboration in space. And of course, the traditionally very strong relations between Belarus and Russia are of course no exception to that. And this cooperation in the space sector goes back many years and has enabled already the implementation of complex projects that advances science in both countries, in Belarus and in Russia. And one of these very concrete examples was the recent very successful mission of a Belarusian astronaut, Marina Vasilievskaya, on board the Russian segment of the International Space Station. And I would like to ask you to tell us more about this project, how this came together and how was it implemented.
Good afternoon. Thank you very much for this opportunity to participate in such a significant event devoted to piloted space launches. Belarus and Russia are strategic partners, and we live in the Union State, and our history of cooperation in space sphere has its stems from back the Soviet Union. We used to live and work together. And Belarus actively participated in all programs of the Soviet Union, and it is still so. And during today, Belarus has competences in the space sphere. The remote sensing equipment, optical electronic equipment, and new materials, space electronics, and piloted cosmonautics was not available for us for a long period of time. Belarus is not a large country with quite high scientific and tech potential, but we cannot use it in space, if we're alone. That's why strategic partnership with the Russian Federation allowed us to implement our ambitious willingness to have a project in piloted cosmonautics. We didn't have experience, we did not have technical capabilities to achieve that, but thanks to the Russian side, now we can use it. We selected the cosmonaut, and the process was done in less than 6 months. And interestingly enough, when we started thinking of our cosmonaut and selected one, we started the selection process, various criteria, professional capabilities, and so on. But as for health of cosmonaut, that should be enough to go to the space. And we thought of the age group from 25 to 40 years. But when we started our real selection process, it turned out that unfortunately, from 40 years we went younger. I mean, 30 years when he is 30, he can go to the space in his health status and some other criteria. So we cooperated very closely with Roscosmos during the process and the Center of Preparation of Training for Cosmonauts. And using this opportunity, I would like to express my sincere gratitude to State Corporation Roscosmos and the Center for Preparation of Cosmonauts and other companies from the rocket and space industry of Russia who helped us in making the pilot, in making this flight. So this flight was intended to achieve scientific research goals, and we articulated a program with close cooperation, in close cooperation with the Russian side, the Russian Academy of Sciences and Roscosmos, and the representatives of the Institute of Medical and Biological Problems. Thank you very much to everyone who participated in the process. It was very fruitful, and we found out the methods and approaches to articulate an efficient program. So it was a short period of time before we started the project. It was a challenge for us to create equipment that is certified to send it to International Space Station, and the scientific program was built with the maximum use of the Russian segment of the International Space Station. And we are very proud to say that International Station photo-video spectral equipment of Belarus production is operating now. It was used in the Hurricane experiment. So we succeeded in this project. So the start was planned for the 21st of March 2024, but due to a technical reason, the launch was not made, the flight was not made, and it was postponed for 2 days, the 23rd of March 2024. For us, it was, well, I would not say that it was a shock for us, but we were all very nervous because such situation did not happen in decades. But thanks to high professional level and work of Russian specialists, the rocket was prepared in 2 days for the next launch, and the launch was done. Marina Vasilevskaya worked in the International Space Station for 12 days, and the launch was made not in two-stage scheme as planned, but 2 days scheme, and our cosmonaut, before docking to the International Space Station, adapted to no gravity conditions that allowed her to work in the station in full-fledged manner. So the landing was the 6th of April. Today is the 9th of April, so the flight is 2 years now, 2 years anniversary. For our country, this was not just an iconic development, but a huge development. The country followed the flight, the whole country monitored how it happened, and it was a very touching moment, very interesting moment, very interesting to look at how the country is responding to the failed launch on the 21st of March and how happy we all were on the 23rd of March. So in our country, it energized the whole nation, I should say. It created huge interest towards cosmonautics in our country, and it gave us an opportunity to show that we can, together with such established leader in the space industry as the Russian Federation, we're able to articulate a program to select a cosmonaut and make this flight. So the flight showed that everything can be done in cooperation. And the crew of the spaceship consisted of representatives of three countries, Russia, Belarus, and the United States. And it showed the uniting role of the space. It showed that the piloted cosmonautics can be effective within the framework of international cooperation, can be especially effective. And the future of the piloted cosmonautics, from our standpoint, is in international cooperation, in joint efforts and activities in this area. Another project I would like to mention now that is not about the space flight. Simultaneously with this project, we also participated in Sirius 23 project. This project was done by the Institute of Medical and Biological Problems. The experiment on 1-year isolation of a crew of 6 people, imitating the flight to the moon. Representatives of the National Academy of Sciences of Belarus, I'm representing, also participated as member of the crew. Olga Mostitskaya was part of the crew, and in this project we also had made experiments Marina Vasilevskaya made at the International Space Station. And again, using this opportunity, I would like to say thank you to the state corporation Roscosmos and the Russian Federation and the Institute of Medical and Biological Problems for giving us such opportunity to try ourselves in such ambitious projects. As for the future plans, from our side, probably it's too early to speak about them now, but if we just think about it, we can say that we, of course, are ready and we're thinking about how to continue our cooperation in piloted cosmonautics. But I think we will see probably the next flight, not a short flight, I think, but if we continue our development, it means we will prepare a professional cosmonaut for a longer flight and participation on the next level in this type of project. So we hope that we will succeed in this, and we will make our efforts to succeed.
Thank you very much, and once again, congratulations to the successful mission. And of course, we all look forward really to see in the future again more astronauts from your country, not only in short duration flights, but also in longer duration flights. I'm sure we'll see that. Let me turn now. Thank you.
Thank you very much.
Let me turn now to Mr. Petrukovic. The space sector has always been a platform for international dialogue. And I think we all remember that even in the time of fierce rivalry during the Cold War time, scientists always from different countries found a way to cooperate. That's actually also the DNA of the International Astronautical Federation that was created actually in the times of Cold War to allow scientists beyond geopolitical tensions and borders to cooperate and work together. Now, with this evolving station landscape with national stations, but the move from cooperative stations to national stations to commercial stations, how does this impact really the cooperation of scientists? How is the scientific cooperation going to evolve under these circumstances?
Okay, good afternoon, everybody. Thanks for invitation to this panel discussion. I think that science, space science, it contributed a lot from the international cooperation in space, particularly in manned space flight, because the International Space Station is a unique object which is built on, which it was possible to build such a big object only, such sophisticated object only due to international cooperation, and supported in permanent operation for 30 years. It opens a wide range of possibilities for science because it has more volume, more people on board, possibility of separate countries to launch science modules, which do not start from the service models, but immediately launch the science modules. And also, it has more power on board, more working hours of crew members, and that contributed a lot for hundreds of experiments on board station. And many of them were international experiments because scientists always want to share competences of each other, to speak with each other. And I know Sergei Krikalev was participant of one of such early experiments, joint experiments on dust levitation on early International Space Station. And by the way, on Monday he told about this on scientific conference in our institute about space science on space stations. And in this sense, I think we need to think what can be the possibilities and new possibilities on multiple space stations. Not on one big space station, but definitely we'll have some period when there will be some several smaller stations, yes, and what can be done? We started, for example, such already discussions with Chinese colleagues in the frame of working group, dedicated working group, to have some joint experiments which are repeated on both stations so we can compare the results and to see maybe send some signal from one station to another. And I think here it is also important to have such, to remember that science is not only uses some advantages of space flight, but also contributes in some way, because science is always very often an umbrella for start of international cooperation. Even remembering Cold War times, Soyuz Apollo flight, many specialists from Soviet space industry were introduced to American colleagues as scientists of Space Research Institute. And they were meeting on our territory just because the industry was kind of not very allowed to visit foreigners. And a little bit later, there was a big program which we actually this year, we are marking not only 65 years of Gagarin flight, but also 60 years of Intercosmos. Intercosmos was a organization, intergovernment organization of mostly socialist countries to start cooperation in space, and it was formally under auspices of academy. Vice President of Russian Academy of Science was the chairman of Intercosmos. And within the frame of Intercosmos, there was a manned space flight of many foreign cosmonauts and a lot of experiments on board space stations, and also several tens of automated satellites were launched. In this sense, I think it is very important for us to think what can be this of the form of collaboration in the new era of the new national space stations. What can we suggest? Russia, as an owner of the new space station, can suggest on programmatic way to for our foreign colleagues. Thank you.
Thank you very much. Yeah, very interesting. You were saying also the introduction of engineers or even managers as scientists in these times. I still remember this, the very beginning of this Austromir project where we worked together in the 90s. It was exactly the case. So scientists have always been a bit the binding link between different communities. We see something like a constellation of space stations in the future. Do you think that this will lead to a kind of competition for customers? And the customers, of course, is the scientific community, so that station operators will kind of try to compete for getting scientists. That may be an advantage for scientists.
Yes, I don't think it will decrease prices, but
well,
I think
maybe.
Cooperation is also, I mean, competition is always good because it will also drive the industry to provide more opportunities for scientists on board, and this is complement to the world science. Yes, if they will be easier to fly, easier to to select what is possible on board, to do on board, what is not possible, less restrictions due to some medical or safety reasons. If there will be faster turnout of the experiment, starting from the preparation, it will benefit to everybody. But I think, strongly think that after some years we will return to some larger international something.
Yeah, let's hope for that. And I think you're totally right. Of course, with a bigger offer of opportunities, I think the time to flight may be reduced, and that really gives benefit, of course, to the scientific community. Thank you. As I mentioned before, what we see today for the future are two different models. We have the model of national stations, which Russia is pursuing, China, India, and commercial stations like in the US, where the industry is given the opportunity to develop, to operate their station, and the government is kind of customer to them. Sergei, question. How does Russian space industry look at this model? Are they envious, or are they more skeptical? Or do you think that such a model of commercialization, a commercial station in Russia, would be thinkable in the future?
First of all, I would like to say that most of Russian industry is commercial. Yeah. So when we are talking about commercial, we probably need also to clarify what do we mean saying commercial station, commercial use of the station, because when you even say that in US you have new commercial companies that build spacecraft, is going to build modules or maybe future stations, but Boeing, which is traditionally a big part of industry, space industry in US, it's a commercial company. So I think it's more like fashion to discuss, to name something as commercial, but in reality, commercial companies for many years and already decades are participant in space exploration. I think one only thing which is also in many cases misunderstood, that many people think that commercial companies, commercial enterprise taking more risk and that's why they can move faster, they can develop more complicated systems, but in reality it's completely opposite. Commercial companies comes to space industry when risk is much less than it was before. In the very beginning, when risk was very high, when uncertainty was very high, it was everything. The biggest risk government took on his shoulder. Right now, because we know what is this risk, and risk became much smaller, then that's why commercial companies start to play a more significant role. And I think because risks still exist, I think even in the US, when commercial companies are ready to build modules for the station, still governmental control and governmental money would be primary to determine which way we are evolving, what kind of activity we are going to have. So we're still going to see governmental participation in pretty significant part of it.
Interesting. Maybe in the case of India, how do you see this? I mean, of course, the Indian space station is developed and will be operated by government. Could you foresee in your industrial space ecosystem something like a commercial space station by an Indian industry?
Yes. As you are aware, in India we are transferring the technology of making the launch vehicles. Recently, we have handed over the technology transfer to Industries Consortium for making the small satellite launch vehicle we call SSLV. We are in the process of handing over the technology of the rest of the vehicles in the coming years, very shortly, so that the national organization concentrates on the development and the research area. Even now, though we call it as a national program, the participation of the space ecosystem in the country is mammoth. And they are with us, and it's something I will say like a husband-wife relationship. Sometimes the husband becomes more powerful and sometimes the wife becomes more powerful. But then it's like a give and take, and the nation always wants the space ecosystem where huge number of experts are working, that to be more profitable. And we are right now building the station with the help of the private industries, not only in India, across the world. And I'm sure that when we get matured into making these stations, certainly in the future we'll be able to hand over these stations, hand over the responsibility of maintaining and making the new stations to the private industries as well. So there are ample opportunities available in India for making these stations in future by the private industries. So they are also in the process of acquiring the entire technology across the world. When they work for different projects, certainly their wherewithal is getting improved to get participated in this kind of activities also. Earlier, to begin with, they started with making of or fabrication of tanks, engines and other things. Then they have got graduated to integrating the systems, and then they are in the process of flying the systems. Days are not far off for them to understand the nitty-gritty of the space station design, procurement and commissioning of these systems in future. Thank you.
Thank you. Yeah, I mean the logic behind the transfer of risk more to the industry is certainly in the US, that more government money wants to be dedicated to the exploration of Moon, Mars, or for further exploration, where the risk level is much higher than on the low Earth orbit. Let me focus on one thing which you have already touched upon before, and that is that, of course, for space systems, redundancy and robustness is extremely important. We've seen this in the ISS program when the Shuttle Columbia accident happened in 2003. The station could continue its operation thanks to the Soyuz and Progress transportation systems. So standardization is important, also redundancy, and I hear that now the plane of the Russian station is also moved to the same as the US commercial stations. The Indian station is also at 51 degree. So which efforts are really being done in order to provide this interoperability, if I may call it, of space stations? I don't know who wants to, maybe Sergei, you want to comment on this?
I can start, because when we discuss how we can operate for cislunar station, when we discuss future development, we start to talk about joint systems, and also we need to decide how we are going to dock, how we are going to live on the station, what kind of power is going to be on the station, what kind of data transfer, heat exchange, and a lot of things which usually people living on the ground don't think about. But in reality, in space, many things are very important. And looking back to history, because we are going back and forth, actually before even Soyuz Apollo flight, but when this Soyuz Apollo flight just started, the first question was how to dock. And it was actually interesting that it was not the same docking mechanism. Just general geometry of a mechanism was developed. then requirement for force and momentum on this mechanism was determined, and then each country developed mechanism themselves. So special androgynous docking mechanism was developed, and Soyuz was able to dock with Apollo. Cosmonauts, astronauts were able to open hatch and handshake in space and work together in space. For International Space Station, we use the same docking mechanism when we dock with androgynous docking mechanism. But for the future station, I think it's also very fine equilibrium. If we are going to do everything the same, it has some advantages and some disadvantages. Because if you make mistakes, these mistakes just multiply. So maybe it's good even to have something different, to be able to have a variety of solutions, and maybe one solution would be better than another, but we need to settle interfaces. Interface geometry of docking mechanism should be the same. Some kind of communication system should be the same in order to be able to talk from one vehicle to another when we do joint operation. Maybe some data transfer should be compatible, but the rest of it can be different.
Thank you. Maybe a similar question also to the user community, rather. Maybe, Mr. Mudau, you as a user of such platforms, how important for you is it that there are standard interfaces for experiments? So you develop an experiment and it will be able to fly either on the Russian station or on an Indian station or on a commercial station. How important is this for you?
Thank you very much, Christian. As I said earlier on, for us as emerging space nations that of course have ambitions to move towards intermediate to the advanced space nation, I think these developments are quite strategic for us, as we are going to be offered quite a number of platforms with a number of opportunities for us to be able to participate and also contribute to the global space economy. I mean, when I look at Africa and I look at the advantage that we have with the youth dividend, I think this is going to create such a hype in the African continent, where these young scientists, engineers, and technologists can be offered a platform for them to really contribute and, of course, demonstrate the skills and talent that they have in Africa. So I think this is a huge opportunity for emerging space nations to participate in the global space program. Thank you.
Thank you. Well, as I said at the beginning, I think it's very important to be able to preserve the experience which we have gathered in the cooperative work that has been done so far on space stations. International conferences, fora like this one, of course, I think that's very important that the global community can come together. How do you see the role of such international fora? We from the IEF, for instance, we are organizing the annual International Astronautical Congress every year in a different place worldwide, bringing together more than 10,000 people talking about all the different aspects of space. How can such gatherings really be nurtured even and used better in order to have better coordination in this future changed landscape of human spaceflight in low Earth orbit? Who wants to say something on this, Mr. Mamambetov? Yeah.
As was already mentioned here, the national stations, of course, should have some integration systems for us to be able to exchange with each other. And also the list of equipment is important for it to be the platform to do certain research. And it is very important here to coordinate and maybe even tell each other, even if the stations are national, to prepare the ground for international cooperation in space. And needless to say, this should be discussed on the ground. The initiatives of this kind of forum with such great moderators as you. Just to add to what was said, first of all, it is very important for the people of different areas of space activities get together. And a very good example here is what we call Association of Space Missions, Space Explorers, when astronauts and cosmonauts of different countries get together to discuss different things. And the safety issues, safety questions and opportunities to help each other started to be discussed there. It's the compatibility of different systems in different countries for us to really be able to get aligned at one forum to do things. And besides such big fora, very important are specialized for the scientists, for instance, when they get together to say, well, for this area of physics we need this kind of experiment, and you guys have to do something. First, to continue talking, maybe at a more specialized level, and to get down to business from words, because as soon as we start doing things, some questions arise we have to solve, and by the end of the day we find solutions.
Dialogue, I think, is the basis and the foundation of cooperation. Talking about open dialogue, I would first of all thank the audience for being with us, listening to all our panel, but also give the opportunity to you to ask questions to our distinguished panelists. So if you have any questions, just raise your arm. We'll have microphones. If you could just, I see here a question. Do we have a microphone here first? If you could introduce yourself, please, and then tell us to whom you address the question.
Very good evening. This is Anup Srivastav. I'm Counselor of Space from the Embassy of India, representing Indian Space Research Organization, along with Dr. Asir Pakiraj. So I have a social technical question. Anyone can answer. However, Mr. Krikalev will be the most suited one to answer this. We still understand that the International Space Station and forthcoming stations will continue to be technologies of the elite. Still, what disruption, I do not say innovation, what disruption in technology as a cosmonaut would you like to suggest which makes it more accessible to common people? All the experiments and the outcomes of space station still continue to be the propriety and the technologies of the elite. Is the question? Yeah. If you want, I can ask to interpret.
Okay, maybe.
So the question was, the space station and associated technologies continue to be the technologies of the elite. What disruption we can introduce, not just innovation, what disruption we can introduce to make it more accessible to people in general?
What do you mean saying disruption?
It's not just changing the technology. What fundamental change you feel should be brought in the overall system to make it more accessible to the common people?
Still, I think it is going to be accessible not to common people, but more to specialists. That's first. And second, and also to be the specialist, you need to be well educated, have experience in working in this area, so you became elite also. So that's one note, I would say. And secondly, I think that station became more and more accessible. for different experiments. For example, we just recently discussed it on a scientific forum in IKI that actually before, if you want to make some kind of experiment or you want to build or test maybe some future communication experiments or maybe make some kind of Earth observation equipment, you have to build all satellite with all systems on it. And it's pretty complicated and requires a lot of experience and money. For human space flights, that's actually would be probably the answer. The human space flight, when station is already built, the station is like big laboratory that provide you infrastructure, and you don't need to build wall and foundation and roof in order to make experiment. If you come to the laboratory, you can come with your equipment, plug it in a power source, connect it to heat exchanger and conduct your experiments. The same can be done on International Space Station. If you want to do specific scientific experiments, you don't need to think how to launch it on orbit, how to provide communication link, how to provide power supply. You can put all your knowledge and all your experience in scientific part of it and bring only this box that can be plugged to station power, station heat exchange, to communication line to downlink the data. So that's probably what is already done. And actually human space station where what is more or less universal is actually give you opportunity to be part of space exploration and not necessarily be a spacefaring nation.
Thank you. Do we have more questions? Yeah? Yes, Mr. Petrukovic, please.
Instead of technical answer, the philosophical answer. The answer is one word, anti-gravitation.
Colleagues, good afternoon. I'm a student of Moscow Aviation University. My name is Michael. My question is to Sergei Konstantinovich, and I would like to find out, because you flew at the Mir and you were the first at the station, and you are now designing the new one. So what is the technical solution of the ROS project is the most interesting for you, and why? Thank you. Well, the technical solutions for ROS are not yet adopted, because now it's in the design stage of the station. One of the important peculiarities Christian was talking about at the beginning as to how we would like to transfer our experience from one system to another, from the previous stations to new stations. And we've seen it already when we were getting from Salut to Mir, and a number and some of the successful Mir Salut stations to Mir, and a lot of experience then we got in Mir we transferred to our ISS, and that's made it successful. And what I think here is that working at the future stations project, ROS or maybe some other stations that will be flying, to provide this kind of connection, not to have a not to start from scratch, to provide this continuous transfer of knowledge, experience. And by the way, exactly we in this respect, we did discuss it several times with our US colleagues, and NASA and us, we think that this piloted program continuity is very important. And they did have some negative experience in the USA. When one program had been finished, the new one lagged behind, and then to resume, to recover the experience was very difficult. Not only the knowledge, because knowledge somehow you can put down on paper and transfer, but I mean it's human experience, because some things, like they know how to do it with their tips of their fingers. It's something to provide seamless transfer of knowledge and seamless transfer of experience and technology for the station to be viable and reliable in the future. My question, the high-ranking panel shows that we have to raise a global question, very strong question. You know, Tsiolkovsky was dreaming about interplanetary life, and Elon Musk now and Bezos, they are talking about that, saying they didn't appropriate it. They are very respectful, especially about the type of civilization and Elon Musk. Well, that's great, but the orbital stations that in the world they do exist, the Chinese one, for instance, they plan to issue special CubeSat satellite to research space weather, and so the orbital stations becoming orbital university. And our cosmonauts from our stations, they go in outer space, and students and school children can work together with the elite orbital stations. And that is why it seems to me, well, maybe the answer to the previous question, because we don't have much time. Yes, if you have a question, you're welcome. My question is, what are the plans in Kazakhstan, in India, and in South Africa, and in Moscow, in Roscosmos? Are there any plans of such educational scientific programs that using AI can become educational track for the global orbital university? Well, AI maybe should go beyond here. We should not maybe speak about that. But as for educational things, we are already doing it and been doing it since Salute stations. In Mir, we were doing it, educational experiments, a lot of them, and the U.S. segment also, our colleagues doing that, European colleagues are doing that. So we continue it, and I think it will be expanded only.
This is a very important question that was asked, because I think today here we've already demonstrated the principle, two principles, the principle of diversity as well as the principle of inclusiveness. Hence, we seeing as South Africa emerging with a limited budget, being invited to participate in space exploration. ISRO friends have invited us to contribute a payload in the G20 mission. So I think what's critical is that our governments, we need agile, strong leadership that can begin to invest in space education as well as in building human capital so that you can have these highly competitive scientists and engineers. Thank you.
Thank you very much. Want to add something?
Yeah. That's good that as we all concur, we are going to work together, unity in diversity. And certainly, all the questions which have been asked have been well taken, and the training of the future younger generation also need to happen in parallel as we prepare for the future. One thing I was about to tell, in the sense, see, we have the players from, in football, the players from South America, they are able to play in the clubs of Europe. And in the Indian Premier League cricket, which you are watching now, all across the world, the players are able to play together as a single team in the clubs. The very reason for they are able to perform together is the rule of the game is same in any continent. I would request, especially when Mr. Christian is here, when he is going to moderate the sessions every year under the aegis of the International Astronautical Federation, that the rule for the space flight, the human space flight, should be brought to be the same rule. In rationalizing the systems for the station, docking, the platforms, what is being provided, if the rule of the space station is going to be the same, I think all the questions which the people have asked will be answered very comfortably. And I'm sure that interoperability, what we are really aspiring for in future, will be resolved when we have the rule of the space station same across the globe, in whatever you look at. Thank you.
Thank you very much. I think this was a very powerful plea for cooperation. I would like to thank my speakers here, but I would not like to let you go before asking you one question, which a straightforward answer in one word. We have been discussing low Earth orbit, but of course the whole world also looks ahead already in far distance exploration, and the moon is in the focus. I mean, as we speak, as I said, Artemis 2 is just around the moon, soon on the way back to Earth. China is also very pushy in putting the first human Chinese on the surface of the moon. The US has announced to be the first on the moon, so there is a real competition specifically between the US and China. I'm really curious to learn from every single of you who will be the first, US or China. Let's start with Mr. Petrukovic. It's a dangerous question, I know, but...
China.
Mr. Pucha.
The state who will have very realistic and positive result.
Mankind will be the first.
Mankind, yes, good answer.
I also would say a human being. And I would agree, human being, the mankind will be on the moon, and I don't know which nation would be the first.
I concur with the panelists. Thank you.
Well, I was not able to get really a clear statistics out of this, except for Mr. Petrukovic, who has a clear opinion. Thanks. Still, I agree with you. It will be an achievement for humankind, and that is based on all the experience and the great work in low Earth orbit on stations.
You were trying to have statistics from two choices, but actually it's three. That's why it confused you.
Thanks a lot for enlarging this. So once again, thank you very much to all my speakers. Please give them another big round of applause, and thank you for being with us.